respected professors and my dear fellows, Assalamu alaikum. I'm Abu Said Sajid Ahmed. Today, I'm going to present our work, a hybrid approach to detect injection attack on server-side application using data mining techniques. We'll see data plays in a significant role in making decision in almost every field we know. It is considered the fuel of the fourth industrial revolution, so it is important and challenging task to secure the data. According to a report, more than 200 organizations, including LinkedIn and Zoom, faced severe cyber attacks. In 2013, a billion accounts were hacked of Yahoo. In 2015, 117 LinkedIn IDs were hacked, and in 2020, almost 5 lakh Zoom. All the cyber attacks, injection attacks got the highest rank in web security. In injection attacks can take place in both SQL and NoSQL databases. From 2010, around 4 lakh SQL injection attacks are happening on a daily basis. Now I'm going to discuss what problems we're going to solve and how we're going to solve it. Hackers inject malicious codes in request object or request URL that is sent to the application layer for execution, and all the data inside the database are hacked. So we built a 2 layers firewall service that detects those malicious codes and blocks the malicious query from executing. Now I'm going to discuss how we got to the idea. In this paper, authors did a very hard work to detect the NoSQL injection attacks. They built their own dataset as there is no dataset available at that time. They built their own tool to detect NoSQL injection using supervised learning and got an accuracy of 91%, which is pretty close to our result. In this paper, authors tried to detect SQL injection using decision tree classifier, and they used both static and dynamic approaches, got an accuracy of 99.4%. So according to the survey we have done earlier, we found that both machine learning and non-machine learning approaches are used for detecting SQL and NoSQL injection attacks. So we decided to make a 2-layer security firewall in the server-side application. First layer will detect a common malicious query in the request object using a simple searching algorithm. And the second layer will detect malicious codes using the machine learning approach. We also proposed how to use these layers in the server-side application in an optimized way. We implemented our own rule-based model for feature extraction and several techniques, including wrapper method for feature selection. We also use GridSearch-CV to evaluate the best model. Now we'll understand the architecture a little more deeper. We'll see 3 scenarios to understand the architecture. In scenario 1, when the hacker sends a common malicious codes to the target server with the request object, HTTP server sends it to the middleware, and middleware passes it to the first layer of the security firewall. And as it doesn't contain any common malicious payload, the request object will be blocked and will not execute further. In scenario 2, when a normal user sends HTTP request to the server, the HTTP server sends it to the middleware, and middleware sends it to the first layer of the security firewall. And as it does not contain any malicious payload, the security firewall sends it back to the middleware, and middleware sends it to the controller, and controller will construct the query from the request object and send it to the second layer of the firewall. And second layer of the firewall will classify it as a non-malicious query. So it will execute the database operation and sends the normal response to the user. In scenario 3, when the hacker sends uncommon malicious codes to the target server with the request object, the server sends it to the middleware, and middleware passes the object to the first layer of the firewall. And the firewall will not find any common malicious payload, so it will send it back to the middleware, and middleware pass it to the controller. And controller will construct the query from the object and send it to the second layer of the firewall. And second layer will classify it as a malicious query, so it will not let the execute database operation further. So you see, even if a hacker manages to bypass the first layer, he can't bypass the second layer. To build the first layer and second layer, we needed the datasets. So we collected NoSQL injection dataset from GitHub and SQL injection dataset from Kaggle. In NoSQL dataset, there are almost 1,254 rows where the ratio of majority and minority class is 80-20, and in SQL dataset, there are almost 30,000 rows where the ratio is 63 and 37. So we can see a huge imbalance in the data that might affect the performance. Our data set contains the sample of tautology, union query, piggyback query, logically incorrected, and stored procedures in the SQL databases, SQL dataset, and the JavaScript injection, piggyback, tautology, and union query in the NoSQL dataset. In pre-processing, we have done like removing unnecessary space and new line, removing row containing null value, replacing %20 and 21 with space, and creating space at both sides of operator like equal and first bracket in NoSQL databases. And in NoSQL dataset, we have done pre-processing like splitting query and label and removing extra colon, etc., etc. We designed our own rule-based model to extract 24 features from SQL dataset and 15 features from NoSQL dataset. And for feature selection, we performed some feature selection tasks by removing features of zero mean value and removing highly correlated features, and then performed the wrapper algorithm to select important features from the remaining features. And the environment. We used Google Colab VS Code to write our own code and Postman to send malicious object to our server, and Node.js, MongoDB, and Postgres to build our target server, and Flask microservice to deploy our hybrid firewall model. On an imbalanced SQL dataset, AdaBoost and Random Forest classifier outperformed other classifier with accuracy of 97.9%. And on imbalanced NoSQL dataset, SVM got the highest accuracy of 91.5%. But after resampling the SQL injection dataset using SMOTNN technique, we see a huge increase in the accuracy for SVM, AdaBoost, decision tree, and random forest classifier. And same goes for NoSQL injection dataset. In summary, we are first to build the two-layer security firewall microservice using both non-machine learning and machine learning-based approach to detect malicious codes from the text-based data. And in future, we have plans to detect malicious codes in the image data too, and also we are gonna use the neural network model for it. Thank you. If you have any questions.
Thank you, dear audience. I mean, if you have any question and suggestion, please ask. No question. Okay, my first question is, have you calculated feature importance? I mean, which feature is dominating feature?
Yes, we have done it using wrapper algorithms like forward selection and backward elimination.
Okay, so you have calculated the feature. I mean, so which are the dominating feature you found in your feature selection?
Almost 17 features among 24 features in SQL injection dataset, and 12 features in the NoSQL dataset are found in very important. These are on our paper. We didn't show it in this slide.
Second thing, you have mentioned about the rule-based approach. Can you please explain that part? Because in your presentation, you have not mentioned about this one.
Rule-based model is basically the function set of functions where I was talking about is we build 24 functions to extract 24 features from the data set. So we are calling it as a rule-based model. Suppose I want to extract a binary type features 0 or 1. So what I'm doing is simply do some calculation and returning it as a 1 or 0 as a feature. So all the features I'm calling it as a rule-based model.
Okay. Is there any question? Okay, let's move to the next presenter.
I have one question. That is, the firewall only can actually filter the malicious from the text data, right?
Right.
So currently, you have implemented only for the text data. What about the other form? I mean, any other source of malicious code?
Like in images,
right?
In file,
right?
We didn't make any features for handling the files, but in future we have plans to make it using neural network because we have to convert those files into images, all the files into images and classify it using neural network model. So we have plans to do it in the future.
Okay, okay, thank you.
Thank you, Sajid. Let's move to the next presenter, paper ID 121, Stride-based cybersecurity threats modeling for IoT-enabled precision agriculture systems.
Assalamu alaikum. Am I audible?